many vast number of factors that impact and affect selection of components. I will just wrap it up with some very important factors that majorly have been covered by my fellow colleagues, but I will just try to put more light on just some of the factors. And first, I will take you through the company that I'm working for. What is it all about? So we are the largest module and cell manufacturers in India. It's a 1.5 gigawatt module manufacturing facility and also a 1.5 gigawatt cell manufacturing. It's the only company which manufactures 1.5 gigawatt cell in India. We have all the certifications which are required for a module to become a tier 1 module, and we are the only company from India which is among one of the best ranked internationally and highest bankability in international market. We also have all the testing facilities which are required for a module to be manufactured in-house. That make the module work for a long period of time, 25 years and beyond that, and which should be the basic criteria. It's a state-of-art only factory in the world which will have 3 floors, and all the floors have module assembly lines and cell manufacturing lines. The equipments that we use are best in the class, European manufactured, and the efficiencies that we have in our modules is at par with any international module that you have in the market today. And the best part and the good thing about us is that we are now ramping up the capacity up to 3 gigawatts. In a very short span of time, we will see that coming up. So what is Adani Solar PPC doing other than manufacturing of being the largest manufacturer of modules? So we cater to all type of solar projects, be it ground mount, large scale, RCC roofs, carports, water pumps, floating solar industrial roofs, whatever you have, or even the institutional customers. Whatever you need, we have that in our portfolio, and we give all the support to engineering, which is our forte, because we are already more than 3 gigawatts installed and going to be 5 plus gigawatts in a year or so, because the projects are under construction for our parent company, for our another green energy company. So coming to what are the requirements and how you look at a plant when you start it. So the first thing that is the solar project as a whole is the land acquisition and the ROW. Then we have a power purchase agreement, which if we are doing projects ourselves as an IPP, like Renew is an IPP, so they do projects, so they have to settle the power project PPAs. Then we have to select the sourcing of material from reliable sources, reliable manufacturers. We have to also get the regulatory clearances, financial closures have to be done, and project execution, and later on the O&M of the project, so that the expected generation, which has to be there for 25 years, is achieved unless you want to get penalties. So what are the preliminary inputs? What are the factors that affect the design of plant, factors affecting the performance of the solar plant, and the LCOE, how we can get the best out of that. So you first have to see what is the location of the plant. As my learned colleague from Renew said, it's very, very important that you know what is the exact location of the plant. So you visit the plant, you see the land, you see the soil type, you see the environment that is prevalent there. Then there is a type of installation, whether it is ground mount, whether it is whatever capacity of the plant, what is it, what is the expected generation, CUF, what is the transmission line distance, that means how far is the substation at which you are going to connect, and what is the evacuation voltage at which you are going to evacuate the plant. So what will we look at plant location? that is the latitude and longitude, because then you know the angle of inclination of a solar module, which will be the optimum angle to produce the best generation. You can have 2-3 types of angles. You can have seasonal tilts, wherein you can keep 2-3 angles to optimize the generation during various seasons. Then irradiation level is there, so you would want to have the best GHI, that means the best sunlight falling in your plant, so that you can generate more. Ambient temperatures are very important, because efficiencies of module inverters, they will fall as the temperatures go up. So you have to see what is the temperature, because we are not really bothered about the temperature. We are really looking at the light falling on the plane of the module. Wind speed and direction, which is important, because you want the modules to hold onto the structure and the structure to be holding onto the ground. Unless you, otherwise they are going to fly off. Similarly, that is also important, because if in any case you are on the roof and you're already at an elevation where the wind speed is higher than what is at the bottom of the building, there again you have to put a lot of emphasis on what is going to be the wind speed and how I'm going to build the structure. Type of soil will be basically for a ground mount solar plant, because there are various types of soils. There can be a hard rock, there can be soft murram, there can be black cotton soil, which is a very soggy soil. So accordingly, you will be designing the foundation depth or the width of the foundation. I remember in 2011, when majorly this national solar mission came, most of the people decided to the people who started construction. I remember we used to have 500 mm dia, 450 mm dia, 2.5 meter depth of the pile. We used to use a lot of concrete with rebarring, but that has changed. But that doesn't mean that if that has changed, the design has been compromised. Now people have learned and they have become more efficient in designing. So this is very important, because when we see soil, we see what is going to be the depth. What is the meaning of depth of this foundation? Is how much effort it will take to pull out the foundation from the ground, which means the pull out test that we conduct, or the wind tunnel test we conduct, we see whether there shouldn't be any impact if there is high wind. Capacity of the plant is also very important. It can be as per the tender. If it is a tender, then you have to look at the tender or what you win in the tender. Then if it is a private rooftop or some institutional company wanting to have a captive power plant, then what is their load, connected load? Accordingly, you will design the capacity of the plant. That will again define how you are going to construct it. Type of installations, I have already said, it can be ground mount, fixed MMS, single axis tracker, seasonal tracker, which I said, a seasonal tilt also can be there. There can be dual axis trackers also. In the roof mounted, we can only have 2-3 types of it. Can be fixed also. You can have because you don't have much of a space, so the difference of ground mount and rooftop comes there. So you have to design accordingly. Voltage is important. What kind of a voltage you want to design your system at? Nowadays, we are having modules at 1500 volt. So you can design your system at 1500 volt. Inverters are also now available at 1500 volt. That will reduce some of your losses. Grid connection voltage is important, because then you know at what evacuation level you are going to evacuate. That will enable you to understand what is the kind of cable that you want, what kV cable you want to have in the HT side, what is the kind of transmission line you want to, which conductor you will be using to reduce the transmission losses. What is the distance of transmission line is very important, because then you will have to calculate the loss that you are going to incur during transmission of the power from your plant and to the substation where it is going to be metered. So the design of transmission line, what kind of conductor is to be used is also very important, which generally I have seen is neglected somehow. But this is very important factor. Most of the good companies, they don't neglect it. Shadow effects are important when you are designing the array layout. So you have to ensure that there is a difference of some, there is a pitch which has to be kept, say 1 meter, 2 meter, whatever is the kind of shadow impact that you see during the day. Accordingly, you will have to, have the interrow distance to minimize impact on the modules because of the shadow, and that reduces the power generation from that particular string or from that particular array. Technology in terms of what kind of a PV module you are going to use. Nowadays, we are having PV modules of 400 plus. We as Adani also are manufacturing modules of 400 watt peak rating. That is a very, very important factor. The thin film modules were used earlier because the cost was less compared to the crystalline modules. Nowadays, the thin film has gone out of fashion because it's not viable. Uses a lot of land. Watt peaks are low. Crystalline modules and mono modules are getting more into prominence because of their efficiency. Efficiency means you have lesser land required. With less land required, you have less amount of BOS, which will reduce the loss. Less cabling, which will again reduce the cost. Less BOS means less structure, less number of combiner boxes, less number of various other in between things, which generally are the spots where you will lose further a little bit of trickle. Every trickle is important. So these things reduce those energy losses. Inverters, you can use both central and string depending on the area. If you are putting a plant on a hillock, then it's better to use a central string inverter. Or if it is a floating solar, it is better to use string. If it is a good environment where you don't have any kind of high temperatures, then you can also use central inverters, which are outdoor central inverters. String inverters gives a little bit of support in terms of uptime, because you can keep 1 or 2 inverters or 3 inverters spare in your plant. And if there is a inverter which is not working properly, or there is a problem in an inverter, you can immediately change it. Within half an hour, your plant, that inverter will also start running. So you can minimize the impact of an inverter going down by having a string inverter there. Although the cost of a string and central is a little bit different, while string being a little costlier, but when you look at the overall impact on generation, the manpower cost that you're using, the amount of BOS reduction in terms of, if you have a string inverter, you don't use combiner boxes, you don't use string monitoring, because the string inverter has all these features in it inbuilt. So these are some good things. Although central inverter is also modular, but still, even if it is a modular inverter, still you will have to draw out that module, and it will take some time to bring in the new module, while a string inverter can be at your plant. So electrical losses are cable losses, AC/DC losses, transmission losses. We have already spoken about it. Transformer losses are there, so you have to take note of having a transformer which is done in a very well in a good way. It has a right core, a right construction, and the efficiencies of that transformer are good. CUF, plant load factor, these are factors which will come because how the GHI is there, how your plant is performing, what is the efficiency, what is the generation given by your modules, how your transformer is behaving, how you are doing the O&M. So these things are very important when you talk about performance. You have to look at the PRs all the time. Solar irradiation, as we spoke, is based on the location that you are putting your plant in. I'll give you an example. One of my friend, he had installed a plant, and it doesn't matter, that the temperatures are high or low. There can be some severe impact of low temperatures also on your solar plant. Like one of my friends, he had installed a solar plant in Ladakh way back, some even before the solar mission started. And at a particular point of time, there was blue sky, lot of sunlight, and there was snow uh, below the modules, and the modules caught fire. Why? Because the albedo, impact effect came into picture, and the voltage went beyond 1,000. So these factors also are very important. As one of my learned speakers earlier said, albedo is something which is also impacting the generation. If it comes to rooftops, generally it's better to use uh, bifacial modules because you can capture some generation through from reflection from the below. So this we have already spoken. We have to select the right module. We have to select the right inverter. Structure needs to be selected properly, non-corrosive, but high strength. Nowadays, there are lots of good quality material available. There is galvalume, there is Cosmac, lots of good materials which are very strong, self-healing properties. They don't rust that fast, and they are as good as any GI coated structure. These are different type of solar plants. I don't need to get further into it. This can be a central inverter, a ground mount, large scale plant. There can be a ground mount with string inverter also. Here, although it is the string inverters are shown outside, but we prefer to put them below the module itself on the structure which is made for them. And there are capex and opex, different type of projects. Capex is where the customer wants to put his own money. The OPEX is where he does not want to put a money, and we do that project for them, or the investor is somebody else, and the customer is getting the power. And then there is a floating new technology, new type of plants that are coming up in India and across the world, which are floating type of power plants. So overall, if you look at it, there are 2, 3, 4 main